Given that the complex number a, b, c are root of this equation, we are asked to find all the possible value of the triples a, b, c. Using Vieta formulas, a plus b plus c will be equal to 0 because the coefficient of x squared is equal to 0. And AB, BC, CA will equals to 2BC. And finally, ABC equals to -1. So by using the second equation here, we will get AB plus CA equals to BC. And therefore, A of B plus C equals to BC. B plus C from here is actually equals to -A, so this is BC. And this is -A squared equals to BC. Multiply again A to both sides. This is -A cubed and this is ABC. But ABC equals to -1 and therefore A cubed equals to 1. And A will equals to 1 W and W squared. What is W? W is actually equals to e to the power of I 2 pi over 3. And W squared is equals to e to the power of I 4 pi over 3. From Argand diagram, this is 1, -1. This is I and -I. So this is 1 and this is W. This is W squared. Okay. Note that this will be equals to 2 pi over 3, 2 pi over 3, and again 2 pi over 3. So now we are going to consider each of the cases here. If A equals to 1, B plus C will equals to -1, and BC will equals to also a -1. And therefore, BC are roots of u squared plus u minus 1 equals to 0. And u is equal to -1 plus minus square root of b squared minus 4a and c over 2. So this will be -1 plus minus square root of 5 over 2. So in this case, we get the solution for ABC, that is 1, -1 plus square root of 5 over 2, -1 minus square root of 5 over 2. Or 1, -1 minus square root of 5 over 2, -1 plus square root of 5 over 2. So we settle the case for A equals 1. If A equals to W, then you will see that B plus C will equals to -W. And BC is equals to -1 over W. And note that W cubed is equals to 1. So this actually equals to -W squared. So again, we will say that BC are roots of u squared plus WU minus W squared equals to 0. And therefore, u is equals to -W plus minus square root of W squared minus 4a and c over 2a. Now in this case, this will be equals to -W. This is 5 of W squared, so it will be plus minus W square root of 5 over 2. So therefore, the A, B, C here, it looks like the same, except that the A is W. So B can be equals to W, -1 plus square root of 5 over 2, and W, -1 minus square root of 5 over 2. Or W W, negative 1 minus square root of 5 over 2. W, negative 1 plus square root of 5 over 2. Lastly, if A equals to W squared. If A equals to W squared, then B plus C is equals to negative A, that is negative W squared. BC is equals to negative 1 over A and equals to negative W. So BC are roots of U squared plus W squared U minus W equals to 0. And therefore U is equals to negative W squared plus minus square root of W power 4 minus 4, 1 and negative W over 2. Now note that W is actually equal to W power 4. So this is W power 4 plus 4W power 4. And it will be equal to W squared square root of 5 over 2. And therefore in this case, ABC is equal to W squared, and W squared negative 1 plus square root of 5 over 2. W squared negative 1 minus square root of 5 over 2. Or W squared minus 1 minus square root of 5 over 2. W squared W1 plus square root of 5 over 2. So it's interesting to know that if A equals to 1, these are the two possible answers. When A equals to W, the only difference is the multiplication of W to each of the term. And we have this. Likewise, for A equals to W squared, these are the answer. So with this, we found out all the possible answers for complex number A, B, and C. That's all for today. Hope you enjoyed it. See you again. Bye-bye.